Okay, so we're looking at number one. The first thing I think when I see this, the first thing I think when I see pretty much any problem is I want to try to do a u substitution. I think the first thing that comes to mind is u equals 1 plus x squared. And if I look at this, I see something I like, which is that this x looks like this x here, so this is going to work. If I rearrange this so that this is my du, see that this becomes 1/2 1 over square root of u du. And I can just evaluate this integral using the power rule. So let's just simplify this. I'll write that like this. Okay. If you didn't see that, you might have looked at it and immediately thought, let's use trig substitution, so let's see how it would have gone if you did it that way. I immediately see this and I think, oh, I really want this to look like 1 plus tangent squared theta, because I'm thinking 1 plus tan squared theta equals secant squared theta is one of my favorite identities. So I'm going to let x equal tangent theta. All right. Then I have tan theta over square root of 1 plus tan squared theta. My dx, I have it right here, secant squared theta d theta. Okay, 1 plus tangent squared turns into secant squared. Square root of secant squared is just secant on the right domain. Right. I use this identity. I recognize that as the antiderivative of secant. Okay, now what am I doing? I need to know what secant theta is. So let's use this to draw a triangle. Tan theta equals x over 1. And I can complete the triangle like this. And I notice that secant theta is square root of x squared plus 1, which is the same thing I got when I did it using u substitution.